Hello scientific people, I'm back with a good problem from HC Verma, topic X-rays, and here what we have is we have an X-ray tube. Let's don't look at the question first. And in this X-ray tube we have a cathode, we have an anode, and the accelerating voltage is kept to be 69.5 kilovolt. Due to the emission of electrons, these electrons, they travel very fast in this direction, and we believe that when these electrons they come out, their kinetic energy is zero, but when they get accelerated and when they reach over here, their energy increases. So we know that if you keep the voltage 1 volt, then the energy of an electron increases by 1 electron volt. So here the potential difference I have kept it 69.5 kV. So this electron, when it reaches over here, its kinetic energy, since I have assumed that the kinetic energy is 0 over here, so when it reaches over here, the kinetic energy of the electron becomes 69.5 keV. Correct? Now this anode is made up of tungsten. So it is given the anode is made up of tungsten, and here is the atom of tungsten, and the K, L and M shell energies, these are all the binding energies which are positive, whereas the energy of the first orbit of the electron is minus 69.5 keV, because the binding energy is 69.5, right? So that means if I want to pull out this electron outside the atom, or if I want to knock off this electron, that means knocking off means I want to pull out this electron out of the atom, I need to give positive 69.5 keV energy. Less than that I cannot pull out this electron. Yeah, bigger than that, if I supply the energy to this electron greater than 69.5, then I'll be able to pull out this one. Equal to 69.5, I'll be able to pull out this one. But less than 69.5, if I give the energy to this electron, this will not come out of the atom, or nor I can knock off this electron from this orbit. So these electrons, they are going to collide with the atoms of the anode. Now this electron may collide with this, it may also collide with this, it may also collide with this, correct? So if this electron, if I set this voltage, then this electron will gain this much of the energy, and when this electron strikes this or this or this, any of these can be knocked off, because this is having larger energy. So 69.5, during collision, the electron which is going to, this electron which is going to collide will supply its full energy, and this electron will be knocked off, and that electron will also go away, thereby creating a vacancy over here. So when that vacancy is created, this electron or this electron may fall down, which will be liberating K alpha, or which might be liberating K beta radiations as well. If this electron strikes this one with this much amount of energy, then here will be the vacancy created, then this electron will come down for fulfilling the vacancy, that would be L alpha, or the electron from the above shell may come, so L beta may also be released. So for sure, if I keep this much amount of voltage or more than this, then K alpha and K beta, or L alpha and L beta will be released. I mean the photons of the, or the X-rays of these photons will be definitely released. So that means, as per the question, I cannot set the voltage. I cannot set the voltage 69.5 or even greater than that. So what do I have now? Choice. So let's move on. So I have made a new diagram for you. So I cannot keep the voltage which is above 69.5 kilovolt, or I cannot even make it greater than or equal to. Under that situation, K alpha, K beta, L alpha and L beta would be released. So I decide to step down the voltage, and I keep this time 11.3 kV voltage. So this electron, when it reaches over here, it will have kinetic energy 11.3 keV. Now this electron, if it hits this electron, nothing is going to happen because this requires a lot of energy to get it pulled out of the atom. But when this electron hits this electron, definitely this electron may be knocked off, will be knocked off, so thereby creating a vacancy over here, and hence this electron will jump down, and again L alpha or L beta will be released. So that means if I keep the voltage greater than or equal to 11.3 kilovolts, L alpha, L beta will be released. Now if I keep the voltage less than, if I keep the voltage, say for example just less than 11.3 kV, so what is going to happen? Suppose I am keeping the voltage this time as 10 kilovolts. So this electron, when it reaches over here, it will have kinetic energy 10 kilo electron volt. So when that electron hits this electron or this electron, nor this electron will come out, or this electron will also not come out, because they require a very high amount of energy. So what's going to happen is, when that electron hits this electron, definitely this will be knocked off, but the X-rays that would be released would be M alpha and M beta. So as per our question, let's look back. So they are asking that what should be the minimum voltage that I should keep so that K alpha, K beta, L alpha, L beta should not be released. So as we discussed, that if we keep the voltage 69.5 in this slide, if I keep the voltage greater than equal to 69.5 kV or even equal to 11.3 kV, all these X-rays would be released. So I need to keep the voltage just below 11.3 kV kilovolts, and hence I would be setting the voltage just less than 11.3 kV, so that K alpha, K beta, L alpha, L beta are not released. So the minimum voltage that I should set, minimum, would be just less than this one. So we can consider our minimum voltage to be 11.29999 volts, something like that. But if I anyhow round it out, I'll get the answer 11.3 kV. Guys, just remember, the problem has to be understood first, not the solution actually. If you understand what are they asking in the question, you would be able to attempt the question well. Do comment in the comment section. If you have any doubts, do subscribe to my channel as well. Thank you for watching the video.